Welcome to Virelec, a specialist protection and control system supplier. Once the panel and most of the panel components have been received, a kit is prepared. Production department then stages the control cabinets on the shop floor. The panels are preparing for installation of components. Common items such as terminal block mounting rails, wire ducting, and ground bars are installed. Then front panel racking components and mounting plates are assembled on the panel mounting rails. Depending on the work, some subsystems are pre-assembled on the workbench and wired prior to installation in the control panel. Electricians receive the Issued for Construction Wiring Diagrams, or CWDs, as they're commonly referred to in the industry. These drawings detail the wire types to be used and the connections to be made. Alternatively complete, in-panel direct wiring from top to bottom is also undertaken. Once again, the panel gets the usual Virelec attention to detail in terms of careful arranging of wires and looms. Wiring progresses, and tasks are signed off on the panel production tracking sheet by all the relevant personnel. The panel lineup for the project thus proceeds to the assembly and wiring stage, as an impressive lineup of new protection and control panels ready to perform their vital function in our electrical power system. Virelec has a small-run product assembly group that manufactures custom product for specific customers and electric utilities. Typically, these are junction boxes, pole-top RTUs, and other special purpose control cabinets such as DC supply monitoring and spread-spectrum radio transfer trip systems. The manufacture of these products goes through similar processes in terms of component assembly, wiring, and wire testing, and final power-up testing. Following completion of wiring, the panel testing starts. Panel, product, or system testing is driven by customer specifications. In preparation for testing, the engineering department first issues documents and drawings to the test department as issued for test drawings. This enables test personnel to prepare and become familiar with the project and testing requirements. As standard, all Virelec work first goes through physical assembly and wiring testing. Typically, the panel components are inspected and checked for correct location and installation against the layout drawings. Then the electrical schematic diagrams are used to perform point-to-point wiring checks. All wiring connections are documented as being correct on the test drawings by highlighting in a green marker. Following wiring checks, the work then proceeds into live tests. Virelec uses the Omicron test equipment for injection testing and relays on other IEDs. Simulated field quantities of both current and voltage are injected into the relays, and IEDs at devices called test switches. Injected quantities are compared against values measured by the component device under test, and results are documented on test sheets. More advanced system testing, or FAT, factory acceptance testing, as it has become commonly called nowadays, can also involve setting up the communications and networks amongst the various devices in the panels. Typically, testing involves SCADA system point lists containing analog and digital data points. These points are verified by Virelec's engineers and technicians for correct addressing, configuration, and mapping between devices using the manufacturer's configuration and test tools. Many of Virelec PNC panels are now supplied in complete pre-engineered control houses. The control house is a pre-assembled movable building that arrives as the building envelope at Virelec's factory. It's built ready to receive all its component systems such as auxiliary power supplies, termination racks, PNC panels, and telecommunication equipment. The building is offloaded from the transporter and staged at the factory ready to start the assembly and cabling process, much as the same way as individual panels are assembled and wired. Once again, layout drawings are issued for construction. Main components and assemblies for AC and DC power supply are mounted on the walls. The termination racks, where all the final external substation cables will be landed, are installed in the building and secured in place. Once the major wall-mounted components are in place, the floor-standing panels can be installed and braced. Cabling and interconnection of all the components in the building is the next step. Cabling interconnection drawings are again issued for construction to the cabling electricians. This work involves installing multi-conductor cables in special cable trays installed above the panels. Cables are labeled and then individual cable pairs are terminated on the device, and panel terminal blocks within the various panels. Again, as with all electrical wiring connection made, testing has to take place. Testing is a critical step in quality control, and so Virelec's quality management system includes detailed procedures and working instruction for carrying out the required tests. The schematic and cabling drawings are once again the tester's standard. In a typical control house, every single interconnection is point-to-point tested, and the corresponding connection on the drawings is highlighted in green as being correct. These test drawings are an important quality control record. The project is almost complete now. Finishing touches are made to the building. Customer sign-off is handled through a quality control QA release process, and the job is ready for shipment to another, hopefully satisfied customer.